Hello, my name is Gregory Badum, and this is Calculus 2, question 6. So, we have an integral of x cubed times 1 minus x squared under a square root dx. Okay, this one looks very, very nasty, gross, ugly. I don't like it. Here's the thing. This right here is a trigonomic identity that we can substitute out for a sine of x. So we can take this over here. If we have a squared minus x squared under a square root, we can use the following. So basically we're going to take, I'm going to erase all this little extra snazzy stuff I put on here. We're going to have x equals sine of t. Next we're going to have dx equals cosine t dt. So, in using this single variable substitution, we are actually going to have the following equation. We're going to have the integral of sine cubed t times the square root of 1 minus sine squared t dt. Okie dokie. I forgot something. Did you notice? I actually need to add in a cosine t over here, which is going to satisfy our substitution. Okay. Now that we have our actual problem simplified, as you might say, it looks a little more complex now than it did before, but trust me, it's going to work out. Now we're going to make 1 minus sine squared t, which is a trigonomic value, the Pythagorean theorem, cosine squared x plus sine squared x equals 1. We can actually turn this into 1 minus sine squared x equals cosine squared x. So now what we're going to have is we're going to have cosine squared x replace this value in here, which is going to give us sine cubed x t, not x, t, because we've replaced our values. We are going to have cosine x. So why just cosine x? So we can treat the square value as something that we could regularly sub out of a square root. So when this goes back into here, it's going to become cosine of x, because that square is canceling out that square root. So now we have this, I messed up again, it's not cosine x, it's cosine t, times cosine t dt. Alrighty. So now we have two cosine t's that we can just put back together. That gives us sine cubed of t cosine squared t dt. Okay, now it's looking a lot better. Problem is that it's not quite where we want it to be yet. So I'm going to go ahead and erase all of this and go ahead and bring our problem back up to the top so that we can finish solving it. So what we're going to have is sine cubed t cosine squared t dt. Okay, so we can work with this, but we cannot work with this. So we need to separate sine cubed t into sine t sine squared t cosine squared t dt. All right, now that we have this as our equation, we are able to turn sine and cosine into another substitution. So now we're going to do another single variable. It's going to equal u equals cosine t instead of sine t this time. And our du is going to be sine negative because we are deriving it. Sine t dt. Alrighty, so now we have our substitution values, and we're going to go ahead and plug them into this problem. First thing that we need to do though is we need to substitute this out for that trigonometric equation. 1 minus cosine squared t equals sine squared t. So that's going to give us sine, actually let's move this value to the front. 1 minus cosine t, cosine squared t, times sine t, times cosine squared t dt. Okay, cool. Now we're going to sub in these values right here into our equation. So what we're going to do now is we are going to have the integral of 1 minus u squared times u squared du. All right. And you see how I got this, this u squared? So we have cosine squared t, it's a negative value, and u is cosine t, so it's going to equal u squared. So now that we have this, we can distribute u squared into the equation, which is going to give us u squared minus u to the fourth. And we can actually switch these values around if you wanted to, but personally I'm going to keep them the same. Du, and that's going to equal u3 over 3 minus u5 over 5. And we have integrated our formula now. The problem is that we're not done. We have 2 layers of substitution that we need to undo. So we are going to bring this back up to the top. So we have u cubed over 3 minus u5, u to the power of 5 over 5. Now we need to undo our substitution. So our substitution was u equals cosine t. Okay, now we have cosine cubed t over 3 minus cosine 5t over 5. All right, we're not done. We have another layer to do as well. So we are going to have our t is going to equal the value of cosine cubed sine x over 3 minus cosine 5 sine x over 5. All right, now from this point, we can simplify this integral in order to equal the following equation. -1 over 3 cosine cubed arc sine, so we're switching those values, plus 1/3, we have that negative in front, cosine 5 arc sine x plus c, because it's not an indefinite, or it's not a definite integral, so we need to have a constant. So basically, I moved this back to the front, and because it is a trigonometric equation, we have to have arc sine within our cosine values. So therefore, our answer is going to come out to be -1 over 3 cosine cubed arc sine x plus 1 over 3 cosine to the power of 5 arc sine x plus c. And that, ladies and gentlemen, is going to be our answer for the question. I'm just kidding. This is not 1 over 3, this is 1 over 5. Okay, now this is our answer for the problem.